We're now going to leave behind discussing ocean resources and focus more on environmental oceanography and some of the abuses of the ocean. This map shown on this slide illustrates the human impact on the ocean. What effect have we as humans and our day-to-day activities have had on the world's oceans? On this map, areas in blue are areas of very low impact. Areas that are red and orange, areas of high to very high impact. And you can see that most of the oceans here are green to orange. So we're looking at low impact to medium impact. This is changing as time goes on. We see that we're leaving or losing a lot of these sort of medium high impact areas and becoming increasingly more and more high impact and very high impact areas. Data that was used to develop this image includes shipping information on fishing, pollution, things such as ocean acidification, how light changes temperature. Anything you can think of was compiled, and that data was used to create this map. And you can see that humans definitely have a role, and a major role, in impacting the ocean. And quite often this is in a negative way. The first thing we need to do is define what pollution is, more specifically what marine pollution is. And pollution can be the introduction into the ocean by nature, that's an important thing, that nature can pollute as well, or by humans of substances or energy in the form of like heat energy that will change the water quality and can also have an adverse effect on the biological environment, the organisms that make up the different ocean communities. It can have an effect on the chemistry of the seawater as well as the physical structure of the ocean. Even the physical structure of the water molecule. What we see as oceans heat up, water molecules actually increase in size. Some of the things that introduce pollution into the ocean can be volcanic eruptions, it can be the dumping of effluent or sewage into the ocean, oil spills, and a topic that's getting much more recognition in the present day is the presence of plastics within the world's oceans. In the previous slide, we said that marine pollution was the introduction into the ocean, it can be either by nature or by humans, of substances that change the quality of the water. So the things that get introduced into the water are known as pollutants. Once again, these pollutants can be both naturally occurring as well as being man-made. A pollutant will be something that will interfere directly or indirectly with the biochemical process of an organism. For example, you have an oil spill. This oil gets on birds' wings. This has a negative effect on the birds. But once again, the thing that I really want to stress here is that a pollutant can be both naturally occurring or man-made. For example, as we saw in the previous slide, an erupting volcano, it can produce carbon dioxide. We know that carbon dioxide can raise the acidity levels of oceans. It produces methane. It produces sulfur. So there are many ways that pollutants will enter into the marine environment and end up having a negative effect on organisms living in that environment. Once again, there are many different ways that a pollutant can take by which it can enter the ocean. And some of these are fairly obviously. We have an oil spill at sea. We know we have visual evidence of how that pollutant entered the ocean. Other ones aren't so as obvious. For example, we consider a farm. We might have a farm that's close to a river. Pesticides, herbicides, even manure runs off of this farm. They can enter into a river system that eventually enters into the ocean, and pollutants can enter the ocean that way. Acid rain falling over the ocean can introduce pollutants, and this diagram here shows a myriad of other ways by which pollutants can enter into that ocean environment. One final thing before we look at specific forms of pollution is regarding an organism's response. And what we see is that the way an organism, be it an invertebrate, be it a vertebrate, the way it responds to pollutant will depend on its sensitivity to the quantity of the pollutant. Some animals have a very high tolerance for certain pollutants, as well as the toxicity of the pollutant. So sometimes you might have a pollutant in the water, say for example caffeine. There have been cases where they've studied caffeine, especially around the harbors in the waters around Seattle, Washington. They see caffeine levels rising in fish there. People say it's because of all the coffee that's dumped into the water by coffee shops. This might be something that doesn't have a long-term effect or takes the organism can live with for a long time, isn't extremely toxic, and that organism, the fish, are going to respond in a certain way. We also see that pollutants vary in their persistence. So some pollutants will be present in the water column for a short period of time. Some will be present for years and years and years and years. And these usually are the ones that present an area of concern, these long time or these long persistent pollutants, these ones that take a long time to leave the ocean ecosystem. Let's take a look now at some specific forms of pollution. And quite often, one of the first things that comes to mind when you think of pollution in the ocean is you think of oil spills. This is probably one of the most widely reported, both in the media and in scientific literature, forms of pollution, and one of the most recognizable forms of pollution. You can easily and quickly see if there's oil in water and if oil isn't present in water. One of the things we need to keep in mind here is there's many different ways that oil can enter the ocean. And once again, these ways can be man-made. For example, spills of oil, spills associated with extraction of petroleum products at oil drilling platforms, runoff from land sources, even fuel that might be jettisoned by a jet as it flies over the ocean. But we also have naturally occurring oil seeps. And these naturally occurring oil seeps are of interest. We find that they contribute to almost 48% of all oil that is present in the ocean. Here's a picture of a naturally occurring oil seep, and this is one off the coast of California. What you see here is that we see this sort of black stuff, it looks like tar, is being emitted out of the seep and into the water around it. And these seeps, even though they represent about 46 to 48% of all oil in the ocean, they're not of great concern because what happens is they occur slowly over time. And this allows the environment to adapt to it. It allows for organisms such as certain bacteria. There are bacteria that like to break down oil. It allows for them to come in and break down this oil. So we can have the slow seep and lots of time to sort of dispense the results of this oil seep, to get rid of this oil. One of the big concerns is, though, if you have an oil spill in areas of numerous oil seeps. It's very difficult for responders responding to an oil spill to tell the difference between spilled oil and oil from an actual naturally occurring seep. One example is in May of 2015, there was a pipeline break near a beach in Santa Barbara, California, near a region offshore that's famous for all its naturally occurring oil seeps. Their oil seeps released an estimated 6,000 to 7,000 gallons of oil per day. That's a lot of oil, but nothing compared to what was being released by the pipeline. During the response to this pipeline break, one of the most greatest difficulties that responders faced was trying to figure out, okay, which oil is coming from the spill? This is the oil that we should worry about. Worry about it because we've added extra chemicals to it. It's more refined. And which oil comes from the oil seep? This oil, not only does it come out at a slower pace, but we find it's sort of in a more natural state. We haven't gone through a refining process, which makes that oil even more toxic. So many different pathways for oil to enter the ocean. Once again, oil spills is one of these obvious ones, but another way that oil enters the ocean comes from runoff. It comes from, let's say you live near an ocean, you have a car, you park it on your driveway, your car is leaking oil. That oil has the potential to eventually make it into the ocean. Or it doesn't happen that much more anymore with a lot of different environmental laws, a lot more public awareness. People would change oil, dump it down into the sewer drain, and if you're near a body of water, if you're near the ocean, that material that you dump down the sewer drain is eventually going to make it into the ocean. So we see that about 10% of all oil that is in the ocean and pollution that doesn't come from a natural source comes from runoff from urban areas. And this can include the illegal dumping of oil, or as I said, just cars with maybe a leaky cars dripping a little bit of oil that eventually makes it down into the ocean. And then we have oil spills, a concentrated spill of oil. And this is the one that most people are familiar with. This is the one that's going to make the evening news. Quite often what we see is maybe it be an oil tanker. The oil tanker might become grounded. It loses oil this way. A coastal storage facility that stores oil might become ruptured, perhaps during an earthquake or tsunami. Drilling platforms, you might have an event there that causes the introduction, the release of oil into the ocean. One of the big things that plays an important role in just how we should respond to this oil spill and just how bad it is if the oil is crude oil or refined oil. And we talked a little bit about this when we looked at the naturally occurring oil seeps. Crude oil is known as a rough and unprocessed oil. This is oil that is less toxic. It's sort of like a thick, gooey oil, and it basically can smother living creatures. What it does sometimes, or what you see quite often, this is why you see pictures of people going on beaches and washing birds and mammals, is that it covers the feathers, it covers the fur, and these oils prevent the animals from maintaining their normal body temperature and eventually will die from hypothermia. The other thing is these oils don't evaporate, so they remain in the environment for much longer. So crude oils, less toxic, but they have other effects that have a very negative, towards organisms living in the ocean. On the other hand, refined oils, so these are oils that have gone and processed. So these would be oils that might be in a pipeline, might be in a coastal storage tank. These are the ones that we get gasoline from. Their molecules are much smaller than crude oil molecules, so they evaporate more quickly, but they're much more highly toxic to living things. You won't see the smothering, sort of the sticking, these feathers and fur being coated by the oil. It evaporates, but much more highly toxic, and organisms can die either just by simply breathing in the fumes or absorbing these oils through their skin. So there's really no, crude oil is better than refined oil. They both have sort of their positives, if you want to think of it that way, as well as their negatives. To summarize the previous slide, here we go. Crude oil, unprocessed, straight from the ground. You can see it sort of there in the picture in the upper left. Lower toxicity, but as we said, it coats the fur of organisms, it coats the feathers of birds. We see it coating the fur here of the otters, the sea otters, and eventually what it can do is it can lead to death, lowering of body temperature, and death by hyperthermia. Refined oils, once again processed, they evaporate much more quickly, but they are more toxic than crude oils are. What happens to oil when it's spilled at sea? Well, once again, we have this concentrated spill. We introduce a lot of oil into the ocean environment in a very short period of time. If we give it enough time, it will eventually disappear, but not usually within the lifespan of the organisms that are trying to live within this ocean. So there's a couple things that happen, or not a couple, more than a few. We see quite quickly the formation of an oil slick on the surface. Once again, you can easily tell the difference between water that has oil in it and water that doesn't. And one of the reasons why is oils have a different density, and it really won't combine or be dispersed in the water itself. It won't dissolve in the water. Oil can be lost by evaporation as well as photooxidation. It can be eventually sort of break down into smaller and smaller bits, form sort of a water and oil emulsion and disappear that way. We find that it'll eventually make its way, small particles of oil, as sediment. And we also see the formation of something called tar balls. These tar balls will be formed, and then eventually they will be consumed by bacterial activity. So we have, as I said in an earlier slide, bacteria that live in the ocean, and they love to eat oil. These things are great for getting rid of oil in the ocean. So there's a number of different things that happen to oil when it is spilled at sea, or even when it is comes out of a naturally occurring oil seep. What we try to do, though, in response to an oil spill is to quicken that time frame it takes for that oil to leave the system. Here's a picture of some tar balls that have washed up on shore. These are weathered blobs of petroleum products. As I said, they'll eventually be decomposed by bacterial action. One of the things that we use tar balls for is we take a look at them, we take a look at the concentration of them, we take a look at some of the features, what are they made of, sort of like crude oil, refined oil, and we can use them to assess the extent of oil spills, but we can also use them to identify where they came from, the sources of the origin. So if we're a little unsure of where did this oil come from, we can actually take a look at tar balls, and from their composition we can trace it back to its source. So they can be very useful in some ways, if you want to ID the perpetrator of an oil spill. If someone's saying, oh no, we didn't have any spill of oil, you can say, yeah, wait a moment. We have some tar balls here. Their composition matches with what we know is coming from your particular drill site. The other thing that we can see is not only will tar balls form as a result of an oil spill, but they will also form naturally, once again, at these naturally occurring oil seeps that we've talked about in previous slides. How do we deal with oil spills? There's a number of different ways we have of dealing with oil spills. A lot of it depends on if it's refined oil, is it crude oil, and what are the conditions, the weather conditions, the water conditions at the time. One of the first things we do is usually dispersants are released. And these dispersants can be released by plane, they can be released by boat. But what the job of a dispersant is to break down the oil into smaller and smaller chemicals. So we introduce this chemical into the water, and that helps break that oil down. The smaller the particles, it's easier for these particles to mix with the water and to prevent huge slicks from forming. It's also easier for evaporation and bacteria to break down these tiny droplets. So dispersants are an excellent thing to use in treating an oil spill. There is some concern there though, because you're introducing yet another chemical into the ocean ecosystem. But it is one way we have of dealing with oil spills. Another method of dealing with oil spills is called skimming, and this is actually physically removing the oil from the water. What you do is you place these temporary booms. You can see one here, this are the inflated orange tubes in the picture below the text on the slide. You kind of place them in the water. You basically corral the oil into one spot, and then you go through and you remove the oil from the surface. This works best in calm waters. It's definitely not a technique that you want to try in really rough waters. And once the oil is collected, you take it, replace it in collection tanks, and then it is dealt with elsewhere. Another method that I haven't talked about yet is burning. Simply what you do is oil burns. You light it on fire and you wait for it to burn off the surface of the ocean. Once again, this is going to be dependent on a lot of conditions, basically surface conditions. And this little table at the bottom of the slide here goes through, summarizes some of the conditions that are required in order to treat oil. Do we try to skim the oil away? Do we try to burn it away? Or do we try to disperse it? We find that sunlight is an important condition in all three of these. This is great because we know that sunlight is going to lead to evaporation. We see that windy conditions, definitely not for dispersal because you want those chemicals to fall and stay in place to disperse the particles of oil, but not as big of a deal with skimming and burning. Definitely you hope for calm seas. If you have a storm and you're trying to treat an oil spill, recipe for even more disaster. Colder weather, better. And skimming works better near the near shore environment. For burning and dispersing, it doesn't matter if you're in the open ocean or closer to the shore. So you want to also, when you look at the oil, consider, is it crude oil? Is it refined oil? Take a look at the conditions and then determine what method you want to use to treat this oil spill. One well-known example of an oil spill is the Deepwater Horizon disaster of 2010. So in April of 2010, April 20th of 2010, there was an explosion. This explosion was caused by a blowout, an uncontrolled release of oil and gas. April 22nd, 2010, this is in the Gulf of Mexico, the Deepwater Horizon platform. So Deepwater Horizon is the name that they call the drilling platform. It sank and caused, up to this date, and I'm recording this in July of 2019, the largest offshore oil spill in U.S. history. Here's an image taken by our friends at NASA, and it shows the oil spill off the Mississippi Delta. You can see the Bird's Foot Delta of the Mississippi River, sort of in the middle left of the image. And this is what it looked like on May 24th of 2010, and you can clearly see the oil in the water. So once again, oil spills are really a form of pollution that's really easy to see, really easy for the general public to say, oh yeah, there's pollution. We can see it. This pollution or this pollutant is entering into the ocean system or the ocean ecosystem. Here's some information about the Deepwater Horizon spill. I don't expect you to repeat this or be able to reproduce this on an exam, but just for your information, it took a long time actually for them to cap the spill and to stop the spill from happening. So the explosion happened, the blowout happened in April 20th, 2010, and it wasn't until July 15th, 2010 that they were able to sort of place a temporary cap on where the blowout occurred and stop this oil from entering into the Gulf of Mexico. By September of 2010, the well was permanently sealed. Estimates were that as much as 53,000 barrels of oil were lost per day, and the effect this had on marine and wildlife habitats, fishing and tourism industries in this part of the United States is immeasurable. It runs into the billions and billions of dollars. Even today, we're still seeing the effects of this oil spill, especially in some of the marine organisms that were greatly affected by this catastrophe. They're still trying to rebound from it. A final image that shows the aftermath of the Deep Horizon oil spill. Efforts to clean up were extensive. The methods that we've talked about for cleaning up oil spills were utilized. You can see here there's clearly a lot of oil still remaining in the water shortly after when the oil spill occurred.